So we are live. Hello everyone. My name is Tarun. I am community manager at Planet. Today in this live session, we will be covering MLOps 101, the right way to start ML. So we have Ayush Thakur, who is machine learning engineer at Weights and Biases and is also Google developer expert in ML. So he will be sharing his expertise on how to get started with MLOps. So we'll wait for 5 minutes before we get started with this session. So in meanwhile, Ayush, can you share your journey on how you got started with YAML?
Yeah, for sure. Like for me, ML started back when I was in college. I would say second year or something like that. And yeah, like Sent Dex was a YouTube channel that we used to follow. And he used to do a lot of cool computer vision stuff with OpenCV. And yeah, I started doing a lot of OpenCV stuff, then participated in a lot of hackathons with my friends at college, won few, lost few. And yeah, that's how I got a nag. And while I was doing that, I also tried my hands on like app development and web development and those stuff. But ML kind of felt natural to me, and it was like I was just feeling more capable to understand and do like understand ML in general and build a career around that. And it was like really interesting because I've always wanted to be a scientist per se, but ML is kind of somewhere connected to like science in term. I mean, it's empirical in nature. You have to do a lot of experiments. There are many times it's not theoretical. You cannot base the results in some theory. Having said that, it was fun, so I started doing that. Did a lot of ML in my college years. Then got an opportunity to start writing for Weights and Biases. It was an authors program that they launched back in 2020, like start of 2020. And then, yeah, wrote a lot of articles for them. I also got a chance to collaborate with the 2 Minutes YouTube channel. So I used to write a lot of posts for the videos that he was creating. It was like supplementary reading article that one can find more insights about the paper. And yeah, I just was really interested with what Wits and Versus was doing. Loved the culture there as well. So I just like applied and got lucky to get a job there. So yeah, been doing ML in ML. Sorry, I've been then machine learning engineer at WNDB for the last 3 years now. It's gonna be 3 years. It's already been 3 years, I would say, unofficially. But yeah, it's been a fun journey, and right now I'm trying to build impactful projects, try to win Kaggle competitions. I'm not getting a lot of time to like actually focus hard on Kaggle, but that's my aim. And yeah, just wanna do some interesting stuff with ML. So that has been my journey so far.
Well, that's really very interesting. And I guess we can get started with today's session.
Mhm. Let me share my screen then. One sec.
And also, welcome to all the participants. In case you have any questions, feel free to use the chat or comment section below uh, to whichever social media platform you're using, either YouTube or LinkedIn. Feel free to ask any questions. So once we'll take two intervals. In each interval, if you have any questions, Ayush will be answering them. And at the end of the this complete program, we will also have one more Q&A round. So feel free to ask any questions.
Awesome, thanks. Let me share my screen. Mm,
The present. If you can click the present button, you can share your screen.
yeah, yeah. Is my screen visible?
Not
Can you
yet.
confirm? Not yet. Uh,
Yeah,
is
now
it
it is
visible
visible.
now?
Yeah.
Nice. Cool. Let's get started then. So I will today, like as I mentioned, I'm Ayush from OneDB. I'm also a Google developer expert in machine learning. I am a Kaggle notebooks master, but yeah, I plan to be a grandmaster. And then I also contribute a lot to a lot of open source repositories out there, either building integrations like MLOps integrations with OneDB or like contributing in general. And you can find a lot of my work at onedb.ai/Ayush Thakur. That's like where I have written a lot of blog posts and articles about different ML work I have done so far. And yeah, you can find it interesting. As well as you can be, maybe you might be interested to create a profile of your own at OneDB based on my profile. So for the today's talk, basically, I asked ChatGPT, and I hope you all might have heard of ChatGPT by now, about to like say a nice thing about you all who have like spared some time to hear me out on MLOps, right? So it gave a really nice paragraph or two saying that really commend and express my admiration to all of you and etc. So this is an example of a really well built machine learning model which given just a few lines, it's like a question or a request from my end, and it was able to generate so much text like from thin air, right? One who has no idea about machine learning will imagine this to be coming out of thin air. uh, you can also create a lot of really nice looking images using stable diffusion on platforms like Midjourney, Dali, Imagine, etc. There's so many models out there which you can use to create really nice looking images. And now a lot of work is already going on to create uh, speech from text and videos from text. So very soon we might be able to generate GIFs and uh, who knows, like a whole documentary or movie using machine learning, which is really fun. But the question is, how do we build the next effective ML enabled feature, right? Like how can you start imagining or equip yourself to build such a system in future? And today's talk is basically me sharing some of the recipes of building such a system. Right. So every recipe will have few steps, right? In this case, the ML workflow will have three ideal steps, which are we should want to iterate quickly because ML as a field is moving really fast, and we need to iterate as soon as possible over an idea and multiple ideas for that matter. And those iterations should be reproducible because many a times an iteration will be really fruitful. And if you are not recording it, if you're not properly documenting it, you will not be able to reproduce that iteration, or someone else in your team will not be able to reproduce that iteration. So it's very important. And finally, ML is something which is like to build a system like ChatGPT or Midjourney, etc., or Stable Diffusion. It's not something that is done by one single individual. We have crossed that era of machine learning or deep learning where one individual can create a lot of impact. Now it's a collaborative effort. A huge number of ML practitioners, engineers, researchers, and like even infra individuals, folks from like executive levels, etc. They all are part of this collaboration, and we need to have easy collaboration, right? So these are three ideal ML workflows. But before I dive into MLOps in general, let me just touch upon DevOps, because this is a principle which has been matured over the past many years now, because MLOps is still a new term. A lot of companies have started adopting MLOps, but I mean, even the best of the best companies, they do struggle with setting up their infra, setting up their pipeline to be like efficient, cost effective, reduce like time wasted or unnecessary jargons. So DevOps is basically a combination of cultural philosophies, practices, and tools. So say you want to launch an app or build a website. So you or you already have an app or a website. So you build a feature, you test that feature, and then you release that feature, right? That's how, like if you're playing a nice game and they want to add a new feature to that game, they will build that feature, test that feature, and then release it. And then from the customers, they get the feedback and then plan if they want to keep that feature, if they want to improve that feature, if they or they plan out the next features they want to add to the platform, right? So that's how DevOps has been evolved. There's like a strong pipeline and really well tools that folks are using already. So basically, we need to be like while building a system, we need the system to be built quickly. It should be delivered quickly. Whatever is being delivered should be reliable. And obviously, it should be scalable. It should not be that you build a feature and that can only be used by 100 individuals. It should be scalable to as many customers as, is possible, right? And and there are other aspects to it, collaboration, security, etc. So you might have heard the words like CI/CD, continuous integration, continuous delivery. Maybe heard of words like microservices. So these are some of the key terms that have been coined in DevOps, and they are quite mature at this point, right? A lot of services out there are designed with the philosophy of microservices. A lot of softwares have been tested continuously using CI and delivered continuously using CD. So that's like DevOps. So the reason I wanted to touch upon this fact was DevOps has been matured over many years, and almost every company, businesses, products out there that is like building apps or websites or whatever is following those practices, right? So we need to start thinking about how we are doing ML as well, because ML is not just about downloading some data, training, like writing a small model, training that model, and you're done. It's a lot more than that. So when DevOps meets ML, and that's like a quote unquote, right? It's not like all the practices and concepts in DevOps will map one-on-one to ML. So you have to define new words, like new ideas, and coin new terms, and basically think about a lot of challenges that ML brings along with itself, right? Because yeah, it's just hard. So what does MLOps look like today? This was a paper that was published back like a long time back now, and you can clearly see here this black square with ML code. So as students mostly, or academics, we are mostly focused on this ML code part, right? But there's so much more to ML code, to machine learning in the context of delivering that machine learning model to the customers to serve some business requirement, right? So you need to have some data collection pipeline, some resource management pipeline, servicing, feature, etc. So there's so much. One can also say that like if you have a data store, there can be like a whole operations taken care to take the data and train a model, which is taken, like, which one can say ML operations. And then there's another path where you take the data and do analysis on the data to extract more features, understand the data, etc. And that's also part of, the data science teams usually do this, right? So can we club those together and say that this is MLOps? Not sure. One can also say that there are multiple key defined steps in MLOps, like you'll have to have a data pipeline, you will have to have a model training preparation stage, and then there's a deployment stage, so on and so forth. There's a governance stage. So one can also see MLOps in multiple stages, wherein you have a model development stage, wherein you like do exploratory data analysis to understand the data, do the model training. Say if you're writing a model in Keras or TensorFlow, you train the model using model.fit, and then you do some evaluation. And then there's this whole segment of the life cycle wherein you make the data pipeline robust, you deploy the model, get the feedback from the customers. Having said, that's there. Those are the important stages, but every stage will also have different kind of individuals. So like maybe an ML engineer or a data scientist might be training models and doing those exploratory data analysis, but there might be someone like privacy and security expert who might be taking care of governing if the model is actually it's not harmful, it's not harmful to the business, it's not leaking some proprietary data that the company is owning. So there's like the governance aspect to it as well. So bottom line is that an effective MLOps, whatever that MLOps is basically like to achieve an alignment with people, the processes and the platforms, right? So that a concrete business problem can be solved. I mean, ML has already proved itself to it has already proved itself to show that one can do a lot with ML with machine learning. Machine learning can deliver a lot. So it's important to choose the right business problem statements and see if ML can solve it, right? Um, let's move on. Now, I did mention that different stages of MLOps will require different personas, data scientists, machine learning engineers, etc. So the people involved in different components or different aspects of the ML ops lifecycle should be thought of properly. There has to be processes in place which will have a positive impact on the business. You cannot be, I mean, you cannot do ML without proper processes. A lot of companies fail to establish a process that's, I mean, there's no right or wrong, right? But a process which reduces or optimizes the time required to ideate, to have a problem statement, as in a business problem statement, and build a model and deploy that model. So usually, and it's like a old stats from 2021, 2022, that on average, it takes like somewhere around 9 to 10 months for an idea to be from a machine learning model to go from training stage to the production stage. And even then, a lot of the companies which are purely using machine learning fails because they don't have proper processes. And many times, like the decision of the platform that they are using, they can also be a limiting factor. Right. So again, obviously, all the different aspects of MLOps, like on the people level or the process level or on the platform level, will have its own challenges and things to think about. For example, if you're talking about platform, you need to think about the cost and, I mean, the return of the money that you're paying to the platform, how trustworthy that platform is, how maintainable that platform is. If you're thinking about people, you need to think about how you're gonna go about managing the project, because uh, project management for building a website is not the same for building a model and deploying that model. So there's like a paradigm change, and one need to figure out the right processes required. And yeah, that's like one of the many challenges in MLOps. I was talking about platform and to solve a huge mountain of problems, we have a huge mountain of tools out there. I'm not sure if you all can see this image because, I mean, this has been shrunk down, but there are so many tools out there, open source, proprietary, like for different components like infrastructure, experiment tracking, right, analysis, data cataloging, etc. So there's so many tools out there, and obviously anyone will be confused about what to choose, what is actually required for your stack, or your pipeline, even your use case or the problem that you're solving. So yeah, it's a huge mess through which you need to navigate and pick good tools and follow good practices. So if you remember this screenshot in the previous slide, it was like all these steps were kind of squares and rectangles in nature. So like they had like discrete interval between one process to another process or one component to other component. But in today's time and age, it's like everything is kind of getting murky and mixing together with each other. You cannot go about doing data collection without doing data validation or verification. You cannot separate those two things out. At the same time, if you are collecting the data, you need to think about how the features that has to be extracted and how those features are going to play out with your ML training stage, right? So everything are kind of mixed together, and you need to think about everything kind of at the same time when you are thinking about training the model, right? One can chunk things down to like smaller problems and try to solve those problems. But one problem statement, like one sub problem to solve that business problem, will have questions in other departments of MLOps lifecycle as well. You will have to think about verification of the data. You have to think about the extraction. You have to think about the machines or the resources that you have. So yeah, it's a huge mess and it's fun. Now, this was kind of me giving a quick intro about MLOps, the space right now, the challenges, and the things that you need to think about if you are building a system that is going to provide value to us human beings, right? But at this stage, what should be your requirement? What should you be bothered about? And this is me coming from the assumption that most of your students and doing like maybe like studying in a college or doing ML research of your own or as a project for like final year project or something academic in nature, right? So in this setting, you don't necessarily need to think about governance. You don't necessarily need to think about the privacy aspect of like MLOps, right? Like maybe before going ahead, I can take a pause and see if there are any questions. Yeah, feel free to drop in the questions if you have any, or if you want, you can unmute yourself. Would love to answer anything as well. If not, I can go ahead. Right. Now let's talk about now let's talk about some of the goals that you might have, like as the participants of this particular talk. What should be of interest to you? So you might be trying to write a research paper. Many times when we start doing a fourth-year project in college, we think of publishing a paper or two, right? So that might be your goal. And given machine learning is such an important technology route right now, such an important like hype, it's valid to think that this might be one of the goal. You might also be interested to compete in Kaggle competitions and want to win those competitions as well. That might be a goal as well. And if you're not doing that, I would encourage like trying out Kaggle, because that's a great platform to actually hone in your machine learning skills. Or you might be trying to like learn as well as share at the same time. So write a lot of blog posts. You can have your own blogging website. You can host it somewhere else. You can maybe write on recent biases. You can write on Medium, but that might be your goal as well. So beat any goal. I think at this time, it's good to learn a tool or two to make you efficient. And I'm saying so because when you will start to think about getting a job in machine learning or build a career in machine learning, being familiar with a tool or two at this stage might be really handy when you're applying for a job and when you are like doing machine learning for like real business value, right? Now so whatever be your goal right now, you are training some model, and when you are training a model, you might encounter a lot of metrics being generated while training that model. So like the accuracy of the model, the loss of the model, and the model is all obviously trained using some hyperparameters. Like you need to decide the batch size, you need to decide how many epochs you are training that model. Maybe you are using some like fancy objective function, etc., etc. So you can either use a notebook and write things down on a piece of paper, maintain a text file. You can also maintain an Excel sheet wherein you document everything, log everything manually. Or you can use a tool like TensorBoard, which is a great tool, but it's quite limited. So you can like hook in your trading the trading code with TensorBoard, and you can then start streaming the metrics generated to TensorBoard. It's limited. If you're using it, great, but you cannot scale it. So this is great. This is great if you're doing alone. This might be okay if you are the solo practitioner on that machine learning problem. But what if you're collaborating with two individuals, like collaborating with a teammate? What if you're collaborating with two other teammates. So like you're four in the team, maybe a Kaggle competition. So obviously we'll not want to maintain so many spreadsheets, so many TensorBoard sessions, so many text files, right? It will get out of hands real quick, and you will start losing on a lot of insights that you might wanna have access to. And yeah, this is gets crazy as the number of as the number of teammates increases, and that's true for any real life situation wherein, I mean, yeah, like easily 10 individuals are collaborating on a problem statement, if not 100. So how about then communicating the results or the statistics, I mean, all the metrics that you have generated? How are you going to communicate with your teammate, or how you're going to keep a track of it? You can either maintain different Jupyter notebooks, like for each experiment have one notebook. I mean, yeah, one can think of doing so. It's not easy. Or you can like maintain an email thread, maybe create presentations, slide decks, Excel sheets, whatnot. Get on the Microsoft Team calls, Zoom calls, Google Meet, Slack, Discord, whatever, right? So you can, you can use a number of tools out there which are not meant for machine learning, right? Zoom was never meant for machine learning. Zoom was meant for like taking managerial decisions, right? Slack is to maintain the workforce, the staff in a sync way, right? It's not for machine learning. But the most resilient of us would say that, yeah, it's fine, I can take care of it. But yeah, I mean, it's a lot of mess. So let's revisit the three ideal ML workflows: the iteration, the reproducibility, and the collaboration, right? So let's quickly talk about how iteration can be achieved with a tool like weights and biases. So say you are four of you collaborating on a problem statement that can be solved with machine learning. Instead of having four different Excel sheets or multiple TensorBoard sessions, you can have one single source of truth. And this is 1DB dashboard, wherein everyone in your team who has access to this project can log their machine learning training like runs, right? And you will have access. So you can basically see what your teammate is doing, how far your teammate has been able to push the model's performance, etc., etc. And you get a lot of insights. And it's really powerful because it's easy to compare things in the dashboard if you have a single source of truth. And yeah, like you can get started really quickly. Just have to pip install 1DB, do an installation, and start logging metrics. Right, let me actually try to show you a quick dashboard and show you how it looks like. There's a question by Harsha on the, I heard you mention data governance. How does MLOps help in data governance? Yeah, that's a great question. I would say that MLOps is not helping in data governance, rather data governance is part of MLOps. So say a scenario like you are training model on medical data sets wherein you have, as a company, have access to medical records. Maybe you have anonymized the data so you don't know who the person actually is, but still it's sensitive data. You cannot leak it, right? So you need to have a platform or system such that one, the data is not leaked. Two, the models that have been trained on that data, if that model is, say, not giving good results, you need to have ability to audit based on the data that was used to train that data. So you require to have some sort of governance. And then obviously there are other stakeholders in this cycle. I mean, as a company, there will be stakeholders, maybe the person who's providing the data, the hospitals that you are getting the data from. So they will have to have strict guidelines, right? I hope that answered your questions to some extent. Another question is it important to learn DevOps before MLOps? I don't think it's required. It's important to learn DevOps. I mean, to be honest, I didn't even, I mean, I did some of the traditional ML, XGBoost, tree-based algorithms, k-means clustering, etc. but I jumped to deep learning rather quick in my career, and it's totally fine. You don't need to know everything that came before that to actually do better in machine learning, right? So it's you can totally skip, but it's good to like if you want to build a career in MLOps and not machine learning research or machine learning engineering, purely MLOps, maybe then you can consider taking inspirations from DevOps, how they went about maturing the concept to solve a problem. You can do so, but it's totally fine to get started with MLOps. One let me take one more question right now. Can you simplify data pipeline concept? So yeah, see, like a data pipeline will have few steps. You will have a raw data, and actually I will go into it soon. You will have, say, a raw data. So you're getting the data from, say, hospital, your medical data, right? Then you need to pre-process that raw data to, I mean, either you need to anonymize the identity of the patients so that, yeah, I mean, you need to, I mean, that's ethical and that's required to do by like government policies as well in many countries. So you need to have that step, so pre-processing step. Then obviously the raw data might not be directly consumable by a machine learning model to be trained on, right? You need to do some sort of cleaning and validation, those steps in between. So in this just few sentences, you can see that you start from raw data, you do some pre-processing, cleaning, validation, anonymizing, and then you have some sort of training data ready. Then you also need to take care of the splitting of the data set. You need to split the data into train and test and hold out, test and whatever. So that's in a whole is considered a data pipeline, right? There are multiple steps, and the number of steps or the steps involved in a data pipeline will depend on your particular use case. So there's not one single hard and fast definition for that. Yeah, let me actually, I will go to other questions soon, but let me quickly run through a dashboard here. Let's see if I can share the screen. Okay. Mm-hmm. Sir, can you confirm if the screen is shared?
It is visible, Ayush. Now it is not visible again.
Oh, yeah, one sec. Sorry about this, but yeah, I would love to actually run through the things quickly. Yeah, let's see if it's visible. I think I will have to keep switching. So, I mean, this is, I guess my screen is visible. So this is a dashboard, Basin Basis dashboard that I was using while participating in this Kaggle ASL competition. My aim was to basically learn about this data modality, which is, this task, which is skeleton-based action recognition. So I'm not sure if you can see the GIF here, but these are like the different landmarks on your body, the different joints in your body, and then the person is doing some gesture, and you basically need to say, predict if that. What's the gesture about? So in this case, it was tomorrow. So I ran a lot of experiments, so you can see that maybe I can apply a quick filter here to see which of the models I submitted for submission, and then can compare the results. So the best score was this 57, while my personal CV score or my local score was 67%. So I can then maybe see what was done or whatever the hyperparameters that I used to get this score. So you can see all these metrics. You can also see the system metrics like CPU utilization, GPU utilization, etc. Maybe you can look at the different hyperparameters like the batch size, the number of epochs that were used to train that model, the learning rate that was used to train that model. So as a student, as an academic individual, this in itself is really powerful because you don't need to then manually keep track of the hyperparameters that were used to train that model. You don't need to keep track of the metrics. You don't need to keep track of the utilization of the system. Everything is being taken care by itself automatically. And in my case, I was using Keras, and we have an integration with Keras, and we have integration with a lot other platforms out there, but I will talk about that soon. So yeah, I mean, one can get a lot of insight here. Let's see, this is a parallel coordinate plot, and I can see that to get a good score, like, yeah, if the number of frames were 32, and it was trained for 50 epochs with a batch size 120, it was usually giving a better score compared to a smaller number of epochs, right? And same for like, if you're training for 60 epochs, it was not giving that good performance. So maybe the model started overfitting or something like that. So this is like a dashboard that you can start. I mean, you will have a dashboard like this once you start logging things to 1DB, and it will get a lot of insights. Yeah, just like touch the surface, but there's a lot more one can get just from the dashboard, just from the fact that you're using few lines of code and you are starting like logging the metrics, tracking the configurations and everything. I think it's really powerful that way. Now let me get back to my presentation deck. I see a lot of interesting questions coming. I promise I will get to all of them. But yeah, let's think about like, till now I talked about MLOps and how like what are different ideal workflows of an MLOps, collaboration, iteration, reproducibility, etc. And I showed how was the challenges of using like primitive tools like Excel sheet for machine learning, which was not meant for machine learning in the first place, and why we require a tool like Bitvices for that. So right. So now the question is, as a solo machine learning practitioner, you might have questions about the data, try to understand the data, and then you might have questions about how you can train that model and like what are the different things you can analyze while training the model, and then finally the evaluation. If you evaluate the model, how well the model is performing. And those are three questions I really want to share. I mean, the answers to those questions I want to share with you all quickly here. So for the data exploration bit, you can use a tool like Jupyter Notebook, write few lines of code in Matplotlib or Plotly, and you can start visualizing the data. Great, but it's not scalable. And also, for every new data modality, you will have to write a ton of code every single time. Not fun. You might have tabular data. So if you have played with, say, Titanic, like disaster data set, or some other like standard tabular data set, you will have like rows of data and columns, like features, right? So you can use something like pandas to ask some question about the data set. In this case, the question was, what, like, say the industry stack, give me all the companies which has a share less than 100. In this case, Google is one of those companies in my data set, right? And then you can also split the data, I mean, the data frame, do like aggregation, computation, etc., get some interesting results, can plot the data, etc. Powerful, useful, but the moment you move from tabular data to non-tabular data, and a lot of machine learning is non-tabular. You have images, you have audios, you have videos, you have molecules now. Yeah, a lot of fancy stuffs, graphs, right? And you can obviously not use pandas to do so. Like if you try to load your image data set with Panda, you will see the objects in memory along with the labels. Obviously, we are not gifted, like our eyes are not developed or evolved to the stage where we can look at the object and see, oh yeah, that's an image, right? So you need a tool. So that tool, so within Weights and Biases, we have a tool called tables, and you can use tables to log any modality to it, be it images, videos, whatever. And you can also log the labels. You can log other metadata associated to that image or that video, whatever. And I will show an example real quick. And just like you can do grouping in pandas, you can do grouping in tables as well. So it's really powerful, and it's not limited to just few examples. Say if you have ever trained an MNIST model, MNIST classification model, you might have visualized, say, 32 images or say 100 images at max. But they're like, what, 60,000 images? You will not visualize all of that, right? But you can log all the 60,000 images to tables, and then you can visualize as per the requirement, right? And it's really powerful that way. Now, as I mentioned, that tabular is one small piece in machine learning, but there's so many modalities like images. So you need to, and within images, you have object detection task where you will also have bounding boxes overlaid on top of images, and you will have segmentation mask overlaid on top of images. You will have like what, if you are doing 3D bounding box or 3D segmentation in self-driving car use cases, you will have something like this. You will also have audio, so raw audio files, spectrograms that you're generating from those audio files. You might have videos. You might have text files, right? You would a lot of like the ChatGPT is one of the paramount example of a really powerful model that's useful for natural language understanding. And yeah, like basically the point I'm trying to drive home is that if you're using a proper tool like weights and biases, you can log all these data modalities to weights and biases, be it tables or as it is, right? And you can start visualizing things and getting insights from it. And yeah, let me just take a quick stop here, answer some of the questions, and then quickly demo one of the table thingy. Also, Taran, how good are we with time, if you don't mind?
Hello. So we'll take few more questions and we can continue. We have still 20 to 30 minutes left.
Cool. Yeah, so one of
So
the
we have a
questions,
question from
suppose.
Deepak. How to build a portfolio for jobs? What project will catch the attention of employers?
Yeah, I mean, see, to be very honest, don't approach projects with a perspective of grabbing someone's attentions. Do projects that are fun, okay? Because ML is hard and challenging, and the moment you start doing it for like some incentive other than having fun, I mean, you need to have a game plan for sure, but do consider having fun with that, because you need to. And obviously, I mean, just to give an example, a project that might grab someone's attention, it might be an employer or it might be someone, a researcher at some university or whatever, is if you have an end-to-end example, end-to-end project wherein you start with the data and you train the whole thing, do analysis, write about that in a form of paper, in a form of article. If you can like deploy that, and for deployment you can use a tool like Gradio or Streamline or Hugging Face Spaces. So Hugging Face is a great tool, like open source tool out there, which takes care of such components of machine learning lifecycle for practitioners like you all. And it will be great to have a portfolio for that to build a job. I mean, you can also check out different profiles on VanDB. You can check out some of the profiles on Twitter as well and how they are building the portfolios or the job. I mean, the work they are doing. But I will suggest one thing, that don't like do projects that have been done countless times. Right? They will not grab a lot of attention. Do something interesting. Anyone? Yeah.
Next question is there any intersection of blockchains with and ML?
Maybe, I'm not sure. Like I have personally not, like ever been interested with blockchains, but there might be like an intersection. Obviously, like a lot of disciplines right now can be solvable with some ML concepts. So yeah, what's a try?
Okay.
Suppose I have a data that changes every week. How do I keep track of it in MLOps? Right. So this is like an example, like a typical example of like continuous learning, wherein you have a model that's deployed, say for example, and then you are continuously gathering more data, and you want to train your model on the current data. So for that, you need to have something like VanDB. I mean, we at Weights and Biases, we have something called Weights and Biases artifacts, which can be used to version control the data sets. So, and actually, I will demo that real quick, and that will answer the question. Just give me a sec.
We'll take last question, then we'll proceed with the session.
Yeah,
This was
sure. I will demo that.
okay. Is there a way to understand and build a model from IEEE paper?
Uh, yeah, I mean, you need to read the paper thoroughly, and usually one should read the paper twice or thrice to actually understand what's happening. And then once you have like an outline of what the authors were trying to do, you start. I mean, the best thing is you try to find the code if it's available out there, right? If it's not available, you find uh, like a work that was related to the paper that you are reading. Find if there's code for that work, and maybe you can start building on top of that code base, right? Yeah, it's like it's a thing wherein you get better with practice. But yeah, it's doable. I mean, a lot of all the ML research progress has been done for because folks are able to understand and build models on top of the papers that's been published. Right. Let me share my screen. Yeah. So let's take this example of a typical ML pipeline, wherein you start with raw data. As I mentioned, there will be some pre-processing step to create the training data. You take a pre-trained model, so like a ResNet 50, for example. Then using this training.py script, train the model, like fine-tune the pre-trained model, and then you take the evaluation data and then evaluate, right? And that's like a typical pipeline uh, that you might encounter at this stage, right? So let's say if you have an evaluation, which is a bad evaluation. In this case, this cute dog was predicted as paper towel with a lot of confidence, 98% confidence that is a paper towel. That's sad. So, and I mentioned about something called artifacts previously, and artifacts can be useful to build a lineage like this, version the data sets and version the model. So if you have if you are getting the data every week, you can create different versions of the data set and log it to artifacts, right? And then you can, if you want to train your model on the latest version of the data set, you can specify that in your code. Obviously, I can show you better in code, but that would defeat the purpose of this session. You can maybe reach out to me after the session, and I can share some code snippets with you, wherein you can like you can have a pipeline wherein you have multiple data generated on a weekly basis, and you can start consuming those things as well. Right. So coming back to this bad evaluation, this cute puppy being evaluated wrongly. So it might be a flaw in the training file. It might be that you selected a wrong pre-trained model. Maybe there was a mistake in the pre-processing file. Maybe you started with the wrong raw data. I mean, the data might be similar, like semantically similar, but it was still a wrong data to start with. Or the annotations of the raw data were changed, right? So the point being, a bad prediction or a bad evaluation, and in this case we are not even deploying the model, right? It's like evaluated on on your own evaluation data set, because the moment you deploy, it's in the wild, and the customers can throw in whatever they want to throw at it, right? So evaluation, so in a typical simple ML pipeline, there can be so many places where there can be an issue leading to that one Q dot being predicted wrongly, right? And it gets harder because you might have used GitHub to version your code, right? So same way, if you have like a code base when you have a preprocess.py file, you might have used the wrong version of that preprocessing.py file to preprocess the raw data to create the training data, or maybe you are using the wrong version of the training data itself. Sorry, the training script as well. So again, I mean, it just gets crazy and crazy. And yeah, again, the resilient of us will say it's fine, but we can do better, right? So what we can do, I mean, like with using GitHub, we can maybe check what the training version was used for that step, and like what changed, right? In this case, the format changed from BGR to RGB. So the channels changed, and that's why it might happen that the model on during evaluation was expecting a certain format of the images, but it got wrong formats, right? Uh, or maybe the raw input or the raw data change I mean, say for example, in an object detection task, or maybe in a classification task, maybe the docs were wrongly labeled as paper towels. If that's the case, then obviously the model will predict docs as paper towels, right? Because the models will learn whatever the model sees. So garbage in, garbage out. So if you are throwing in garbage, you are getting garbage out. So you need to keep the versions of the raw data as well, and need to know what changed in every version of the raw data. Now talking about the outputs. So obviously, like when you're evaluating, the model will never be 100% accurate, right? If that's the case, then you need to actually think about your model and actually think about your evaluation strategy. I mean, that should not be the case that the model is given 100% accuracy, right? So you need to understand what's the distribution, like what are the different uh, criteria for edges, like, or labels where the model is failing. So with tables, you can do so. You can just group by the true values and see the distribution of the wrong predictions. Right, and at this stage, I will really want to showcase a dashboard before going to collaboration. Really sorry that I have to change my screen like this every single time. I guess I have some permission issues. Right. Let's take this example here. Right. So this is a table for like an object detection with the images from car dashboard. So like maybe a self-driving use case. So if you see the images here, and these images are logged to 1DB and with overlays, right? So you can see the bounding boxes of the different cars. The cars here, you can turn it off and on. You can turn the whole bounding boxes thing on, and you can look at all the different segmentation marks. So you can see that the sidewalks here, which is weird. I mean, the fact that you are logging it and encountering and interacting with it, you can see that a road was wrongly annotated as sidewalk, right? The sidewalk should be maybe this area, but the roads were also annotated as sidewalks, which is a mistake, right? And this way you can actually see that this data was wrong. Go back for the same file ID, correct the annotation, and log it back to 1DB. And yeah, and as I mentioned, it's not limited to just the labels, the bounding boxes. You have all the metadata like the scenes, the time of the day, the number of buildings, etc. Like number of annotated objects. So really powerful. Now let's take a scenario wherein we want to understand what's the distribution of our data set grouped by the different weather conditions. So out of like some 2,972 total images in our data set, 1,000 images belong to a category clear. So they were all captured in the clear weather category. Just from experience, you will know that if a model is trained on a lot of clear images, it will obviously perform better on clear images, but it might struggle big time for foggy cases where there are just two images. So for foggy cases, the model will not be able to capture the rows properly or the masks properly, right? Because it's just seeing two examples of a foggy use case. So what you can do is, if you have this insight, and obviously you cannot get this insight by writing matplotlib code on Jupyter notebooks, right? You need to have a proper tool to get such insights. So what you will do is you will ask your data team to go out there and collect examples in a foggy scenarios and get it back in the pipeline, the data pipeline, right? Let's see if there's any other interesting example I can show here. Yeah, and this is also a Wicks and Bass's report. So like this project was done, I guess, back in September 2022. And since everything is documented properly, I know for a fact that, I mean, different models were used and what was the performance for all the models. For like YOLO 5X baseline, the model was performance for something like this. And you can just find all the metrics there, which is really powerful. And one more thing, real quickly. is this hyperparameter sweep, because if you're training a model, great, you can log the model, you can log the data sets to tables, and you can get insights from the data by using grouping and whatnot. You can also do something like a hyperparameter search using something called sweeps, which is really powerful again, because again, this project was done long back, and I know that we want to minimize the eval loss, right? So the best models which gave the least eval loss and the best, say, the eval accuracy, were all trained for 15 epochs. We're all using a learning rate in the range of 0.001 to 0.0009, right? They all use connext. So there were different model backbones that were used. So WHG, there's a 15, EfficientNet V2, connext, right? These are all the pre-trained backbones that were used. And the best models were all coming from the connext. So obviously you will want to then take this hyperparameter. So like, what's the best model here? The best model had the batch size 32, drop rate of 0.1, 15 epochs, connext. Take those hyperparameters, train it maybe longer, train it with a bigger resolution of the images. You can do something. You can get all this analytical stuff here. Again, also, let's see something fun as well. So you have done this hyperparameter search. So obviously, in order to minimize the eval loss, you can see that the learning rate played a big role, and it has a negative correlation, which means that when the learning rate was going down from 0.1 to 0.001, the model improved, which is which is true theoretically as well. So right there, the theory has been proved that reducing the learning rate improves the model quality. In the dropout, so if you increase the dropout rate, the model performance also increases. And that might be the case because when you increase the dropout rate, the overfitting reduces. So the model was generalizing well, right? So yeah, this is like powerful insight that you can get from using something like hyperparameter search. So that was a bit on hyperparameter search and how you can go about doing that, and how this is also a component of the MLOps stack, right? You need to have a good thinking about how to proceed doing this as well. And let me quickly jump back to my slide deck, and then we can start taking questions because I'm almost done here. Right, this last big collaboration, I have already showed a report to you all, wherein there was the metrics logged, there was some text, there were tables. So everything was documented really well at one single place, right? So all this analysis, all these different, maybe, and if you're doing this, like Excel sheets or test about sessions, etc., can be converted first to a dashboard by logging everything to a single project in OneDB, and then you can go ahead and create your reports based on what you want to share, either with your teammates, with your manager, with your professor, with your, external collaborators, whatnot. You can create a report really quickly, right? And yeah, just quickly want to touch upon the fact that why should you consider using weights and biases as a preferred tool for your MLOps requirement, especially at this stage, is because we are used by almost every big companies out there that are doing machine learning: OpenAI, Meta, NVIDIA, Samsung, etc. So, obviously, if you are trying to get a career in machine learning and want to work at big companies, those companies will be using machine learning. So if you know how to use it right now, it will obviously give you an edge, like while you go through interview sessions or whatnot. And this is the thing that I'm most proud of, is the fact that we are not only working with the biggest companies out there, but we're also working with the biggest open source research organizations out there. And these are the companies which are trying to recreate chat GPTs of the world, the stable diffusion of the world, and it's really powerful that way. And finally, you might wonder that I just showed the tool, just showed like the screenshots and whatnot, but how is it gonna be converted to code? So one, about weights and biases can be used with every ML platform framework out there. Name it, will have some sort of support for that framework already, be it Tickerus, PyTorch, PyTorch Lightning, Hugging Face, whatnot. Almost every, a lot of big, and actually a lot of popular ML repositories, and this number is way more than 6,000 right now, has a Weiss and Basis integration. They all are using Weiss and Basis in capacity, be it versioning the model, versioning the data sets, or the experiment tracking. And the best part is that if you have a code base that you create, if you have a code base that you might have created on Collab Notebook and instrumented that code base with Weiss and Basis, you don't need to change anything in your code base, just run it on Google Cloud or AWS. So it's really scalable. It can run on any infrastructure for that matter. Right. So yeah, finally, just promoting some of the great work that few of my colleagues are doing at Weiss and Basis. We have, if you want to learn more about MLOps in general, and how to use Weiss and Basis effectively, learn about large language models and whatnot, CI/CD, model development. We have a lot of free courses at wnb.courses. You might consider checking those things out as well. And yeah, I see, and I'm really happy that you have so many questions, but feel free to reach out to me on Twitter. It's my handle, Ayush Thakur 0. So just connect with me there and love to answer the questions regarding MLOps, machine learning, Kaggle, whatever. Yeah, we love to interact there. And that was it. Thank you for the attention. Let's take in some questions then. Yeah, we are already 3. Tarun, how long do you want to continue the questions?
We'll see the questions now.
Sure.
5 to 10 minutes.
Sure.
So, how important is monitoring your deployed models? What's the difference between monitoring and model observability? What is a cloud native applications? How much of this do data scientists need?
Yeah, the monitoring of deployed models is really important, right? Like whatever I showed till now, we're monitoring your training jobs. But once you deploy them, you will have to build a production monitoring. That's what now like at Weiss and Basis, now we have a support for production monitoring as well. It was just released a few weeks back, but you need to monitor it because just giving one example, say if you train your model on today's data, the same model, if it's deployed for if that model is still in production for 6 months, the data might have changed. And when I say that, I mean that the nature or the requirement of the customers might have changed, and because of that, a drift will happen, and your model will start performing bad. The model would be really performing well on the data. It was, the evaluation strategy that you used while you use that train that model, deployed it, but down the road it will drift, and so you need to continuously train the model, and you need to have monitoring in place to do so. Then monitoring and observability. So obviously you need to monitor, but so you need, this drift can be one component of observability. You need to have a fresh evaluation strategies every time. You need to, there are so many challenges and questions that you need to answer after deployment as well. So yeah, it's important there. I don't have any idea about cloud native applications, to be honest, so I cannot answer that. And as data scientists, I am a machine learning engineer, so cannot say for data scientists, but having the concepts, knowing the concepts will really be helpful for sure.
So, what are roles in MLOps?
Yeah, it depends on, as I showed, the MLOps lifecycle can be bucketed or it can be fuzzy depending on the use case, right? So say if it's bucketed, it will depend on what you want to do. So you can do the analysis of the data. So can wear the hat of a data scientist maybe. You can maybe wear the hat of a machine learning engineer who is responsible for, say, training the model and taking it till deploy the model as well. So yeah, again, in MLOps, there are so many personas, and every person, depends on what you wanna, like what excites you the most and what you wanna do. But Yeah, I mean, data scientists, ML ops engineers, ML engineers, the government, the data governance guys, the security guys. There are so many personas out there. Even to be honest, the executives I mean, the executives who have nothing to do with machine learning, who are just looking at the business metrics, are a persona in the MLOps lifecycle, because they are the individuals who are they are the actual stakeholders who are evaluating if that model is useful or not. And those individuals will tell the, say, ML lead in the company to say that, okay, the model has been deployed, it's been working fine, but I don't see a business value impact of that. So we need to reconsider something, or we need to change something. So even those individuals, the executives, are also like a persona in MLOps. So they can be considered a role as well. So as I said, I mean, this is like a huge uh, field encompassing a lot of disciplines, a lot of personas. So yeah, I mean, if your product or if your application is using machine learning, I would say like the folks who are even like marketing will fall into the category of doing something with MLOps. Yeah.
Okay,
Uh,
so we have the last question. Can we automate report in weights and biases?
Yes, you can automate reports and wasting masses if you, uh, yeah, there's this repository called TRLX. If you Google TRLX, uh, just leave that. We can automate reports. So we have a reports API, and you can, I mean, say you train your model and you have a GitHub action setup, right? And that GitHub action is basically evaluating your model on some holdout data set, right? So once that is done, you obviously generated some analysis of how the model perform on that evaluation data set, right? So once that is done, you can programmatically create a report. I mean, log like, yeah, and that when you're doing so, you can plot all the metrics, you can plot the tables, you can do everything that you can do manually with the API as well. Okay, yeah, it's doable and it's well documented as well. Right.
Any more questions before we end today's session? And we would also like to thank IIT Guwahati Summer Analytics for joining this live session.
Great then. I hope I was able to add some value to your time. And yeah, if you have any more questions, suggestions, feedbacks about the session, and also like wondering about MLOps in general, machine learning in general, do consider reaching out to me on Twitter. Yeah, we'd love to connect.
Uh,
That's it from my end.
So, if there are no more questions, thank you, Ayush, for sharing your expertise on MLOps and showing different reports on how you can use weights and biases to create data pipelining and for the computer vision applications. It was a great, insightful session, and I guess there are no more questions. Feel free to reach out to any one of us if you have any more questions in MLOps or in general data science or ML or again deep learning. We'll be there to help you out. So
Awesome.
thank you so much. Do you have any more thing to conclude?
No, that's good.
Thank you guys. Thank you for joining.